Staring at my laptop screen, ready for the Python scene. All those lines of text so clean, let's code and chase that dream. Python world, here we go. Write the script, let it flow.
In this video, I'm going to give a brief introduction to Python, its history, some basic definitions, and talk about some of the tools we'll be using in this course. We'll also take our first look at a few Python programs, but don't worry if you don't understand all the Python syntax you see in this video yet. We'll be expanding on and exploring a lot of these ideas in the coming weeks. Also, don't forget that there are assigned readings from the textbook that go along with these videos. It is important to also complete the readings each week, as the videos are intended to complement the readings and not be a replacement for them. You'll need to cover both to be successful in this course. Let's get started with some background on the Python programming language. Python was first created by Guido van Rossum, a Dutch programmer from the Netherlands. Rossum first started working on Python in 1989 as a personal hobby project with the goal of creating a new programming language that would be the successor to ABC. ABC was a different programming language that he'd been a developer on in the past. If you're curious, the syntax of ABC looks something like this. This is a program from the ABC Programmer's Handbook that defines the command to convert Fahrenheit to Celsius. As you might be able to tell from looking at this, it's not the most elegant or easy to use programming language. Python has made many improvements to make the programming language more intuitive and easy to understand, and we're going to be thankful for that once we start coding. You may be wondering why the name Python. Does this have to do with snakes or something? According to Van Rossum, this is a reference to Monty Python's Flying Circus, a popular British skit comedy show that also had a number of movies that you might be somewhat familiar with. The first public release of Python was published in 1991 and was labeled as version 0.9.0. Since that early version in 1991, the popularity of Python has exploded, as has the number of developers working on Python, which has led to the creation of the Python Software Foundation, which is a nonprofit organization devoted to advancing open source technology related to the Python programming language. The Python Software Foundation is the current owner of Python's intellectual property and is responsible for Python's code development. So that's some history about Python, but why are we using Python in this course rather than another programming language such as C or Java? Well, Python has a number of features that make it ideal for learning programming for the first time, and helps abstract away a lot of minor details so we can focus on our main goal, which is implementing the logic of algorithms rather than worrying about memory management or hardware details. Python is also open source and free. In this case, open source means that the source code to Python is available for anyone to view, and you're free to modify it and make your own version of Python if you really wanted to, at no cost to yourself. This also means that Python is free. Open source doesn't always mean free, but in this case it does, which means you can download and use Python at no cost to you. Another important feature of Python for us is that it's a multi-paradigm programming language. This means that it supports both structured programming, sort of like you might see in C, as well as object-oriented programming, like you might see in Java. And this is done in a way where you're not forced into either paradigm. We can write structured programs, or it can write object-oriented programs. This is great for us as it means we don't have to learn a lot about programming up front, and we can dive into making some programs without worrying about classes or objects or those object-oriented programming concepts. Next is Python is dynamically typed, which for us means that you don't have to worry about associating types with variables or even predefining variables before using them. Python handles most of this for us in the background, making coding easier. It uses a system called duck typing, which means if it walks like a duck and it acts like a duck, it probably is a duck, to try to figure out what kind of data type you intended. Python has a strong emphasis on creating beautiful, readable code with simple syntax. This is summed up well by the Zen of Python, a set of 20 principles that define the guiding principles of Python's design. And the 20th principle, not listed here because it hasn't been written down yet. I don't expect you to memorize all this, but I have highlighted some of the important principles, including beautiful code is better than ugly code, explicit is better than implicit, simple is better than complex, readability counts, and there should be one and only one obvious way to do things. And if an implementation is hard to explain, it's probably a bad idea. These come together to make programming language that's focused on ease of use and readability, which is great for new programmers. It also means things like indenting your code are mandatory in Python, which helps us develop good coding practices. Next, Python has acceptable performance. It's not the fastest programming language, and some sacrifices were made for dynamic typing and ease of use, but still holds up well enough to be used commonly in the real world. In this benchmark from Computer Language Benchmark Game Project, we can see that Python ranks a bit low compared to other popular languages. However, unless you are doing something that takes a significant amount of speed, such as big data processing, the ease of use of Python is often worth that performance cost. The last and perhaps most important reason we're using Python is because it's popular. According to a survey of LinkedIn job postings conducted by codingnomads.com, Python is the most frequently desired programming language mentioned in US job postings. This means learning Python could be a great benefit to your future career as a programmer or computer scientist. Even if you're not looking to go in that direction, learning Python could be a great asset in your future endeavors, and it will look great on a resume. Enough about Python's history and background. Let's finally dive in and take a look at some code. Don't worry if you don't understand this code yet. We will be going through each part of this in more depth in the coming weeks. But for now, we want to focus on some basic definitions that we need to know. This is a fairly simple program, and it just asks the user for their name and the year they were born. Then later, it outputs how long ago they were born in both years and seconds. So let's take a look at what happens when we run this code and give it some example inputs. Right now, what you're seeing is a little output window that is common for PyCharm, an IDE that we'll be using in this course. Don't worry, we'll talk about getting that set up and installed in a separate video. So now I'm inputting my name and the year I was born in, and we can see that we get a specific output that says, hello, Daniel, you were born this many years ago, which is this many seconds. So it's great that it's working, but now let's break this code down and explain what we are looking at. The first concept we need to be aware of are statements. Statements are single lines of code that represent some instruction the program will carry out. They're performed sequentially from the top to the bottom, starting with the top and going to the bottom of the source file. There's many types of statements in Python, including assignment statements that assign a value to a variable, expression statements that return the result of a calculation, return statements that return values from functions or methods, and many, many more types of statements. We'll encounter lots more in the coming weeks. The next thing we need to look at are expressions. Expressions are partial lines of code that return a value when evaluated. These can be literal constants, like the year 2024 here. A literal constant is some value that has been hard-coded into your source code and cannot change. An example would be the numbers shown in blue here, such as 2024, or 60, 24, 364.2425, and so on. Function calls that return some value are also expressions. In this case, the input function is being called to prompt the user to input their age and their birth year. Expressions can also be the result of arithmetic, such as the calculation for the number of years or seconds shown here. Expressions are commonly part of larger statements, but can also be a statement themselves if they're the only instruction in that line of code. Next up are operations. Operations are special symbols or keywords that designate some type of computation is to be performed. A common operation is arithmetic, which includes operations such as addition, subtraction, multiplication, division, and so on. These do pretty much what you'd expect, add or subtract values, for example, and they do follow a set order of operations, just like real math. Another common operation is assignment. The assignment operation is represented by an equal sign, and it stores the value given on the right in the variable on the left. We'll talk more about operations and assignment in a future video. Next are variables. Variables act as a container in the computer's memory and allow us to store values so that we can use them later. The variables shown here on the left side of the assignment statement mean that we are setting their value to the result of the expression on the right-hand side. For example, this assignment statement asks the user for their name and stores the result, that is the text the user inputs, into the name variable. Current year at the top of our program here is also a variable, but our intention for this is for that value in this variable to never change. We call that being a constant. In some programming languages, there's a way to specify a variable as constant and enforcing that will never change. However, Python doesn't have a way of enforcing this. So a common practice is to type the variable name in all capital letters to let any other developers working on this program know that its value shouldn't change. A common idea in Python is to give programmers the power to do what they want, even if that might be a bad idea. So Python doesn't have things like constants because that would be putting limitations on the programmer. Instead, we usually have naming conventions that try to give hints at what we should do with a variable. Variables can also occur in expressions. When a variable is an expression, its value is accessed and used in that expression. For example, in this assignment statement, the current value of current year and birth year variables are evaluated to determine how many years ago the user was born. Current year would have the value of 2024, and birth year would contain the year input by the user. Don't worry if these variables seem confusing right now. We will be going into them in much more depth in a future video, likely next week. Next are functions. Functions are blocks of code that allow for reuse. These can be built into the Python programming language like the input, print, and int functions here, or they can be created by the developer. Functions act as a black box where the user of the function does not need to know how the function works. They only need to understand the inputs a function takes, called parameters, and the output, called the return. When we run a function, we call this calling the function. In this case, we are calling the input function with one parameter, the prompt to display to the user. The input function has one return, which is the text that the user input. Since this input function is part of an assignment statement, the result of calling the function is stored into the variable named name here. So to summarize, this line asks the user, it says, "What is your name?" The user provides input, and that input is stored in the variable name. The print function works similarly, but instead of getting input from the user, it simply prints what is given to it out to the screen. In this case, it prints, "Hello, whatever name was input, you were born however many years ago," which is however many seconds. And that's output in the terminal for the user. The other function we're using here, the int function, is basically about casting. What casting is, it means changing the type of something. The input function returns a string, which is text that the user put in, so the int function takes that text and turns it into a number. Again, these sort of topics will be covered in future videos in far more depth, so don't worry if you don't fully understand at this point. Right now, we're focusing on definitions. Our last definition we're going to be looking at are comments. Comments are simply human-readable notes inserted by the programmer to document their code. They're completely ignored by the computer and do not impact the program. In Python, all comments must start with a hash symbol, and they can occur at the start of a line or at the end of a line. If they occur at the start of a line, the whole line is commented out and ignored. If the hash symbol occurs anywhere else, everything else after the hash is ignored. Okay, let's summarize what we've talked about so far by going line by line through this program and recording how the variables are set and changed. This process of going line by line through a program is called tracing, and it's a great skill to have when you need to understand a program you've not seen before or you're trying to debug your own work. It's also an important skill to have for computer science quizzes and exams, as we often have questions asking what the output of a given program will be. Let's get started at the very top of our program. And this makes sense because, as you'll recall, programs and algorithms are executed sequentially, starting at the top, going to the bottom. And this first line that we encounter is a comment. So that means that it's ignored by the computer. We know this because they start with that hash symbol. And remember, everything after the hash symbol, at least on the same line, is ignored by the computer. So the first statement that we can actually execute is an assignment statement, and it sets current year, in all uppercase, to the value of 2024. So we'll make a note of this to the side so we can keep track of the current value of this variable. So right now, current year is equal to 2024. Next, we have another statement, but this time rather than a literal constant, we have a call to the input function that asks the user for their name. For the sake of this example, let's say the user inputs Dan. The text is stored in the name variable, and we move on to the next line. We'll make a note of this up here at the top. Next, this line is very similar to the last, except we're now asking the user the year they were born in. And that string is stored in birth year. Let's say the user inputs 1986 in this case. We get that string from the input function. The in function then turns that into a number, and it is stored in the birth year variable. And again, we will talk more about int and types in a later video. Our next line is also an assignment statement. However, this time, rather than a function call, we have an arithmetic expression on the right-hand side. As this expression has references to the variables in it, Python has to look up the current value of those variables before completing the calculation. The current year is 2024, and the birth year is 1986. So the current year minus the birth year would be 38, and this is stored in the years ago variable. The next line is the same idea, evaluating an expression and storing it in a variable. There is one small thing to note, however. This line also has a comment on it. Recall that everything after the hash symbol is a comment and ignored by Python. The result of this statement is storing 38 years converted into seconds in the variable named seconds. This is accomplished by multiplying the number of years by 60 seconds, then 60 minutes, then 24 hours, and finally 365 days. We could have also just multiplied it by the number of seconds in a year, but this made it a little bit easier to understand in this example. And now finally, we're on the last line. And this last line calls a print function to output the text, hello blank, you were born blank years ago, which is blank seconds. These blanks are replaced by the values of the variables listed in them. We'll go into more depth into how this works in f-strings in later videos. But for now, know that the output in this case would be hello Dan, you were born 38 years ago, which is 11,99164,176.0 seconds. Okay, now that we've traced through a Python program in our head, how do we actually get this to run on a computer? Well, the last thing we're going to cover in this video is how to run and write your own Python code on a computer. Well, to write and run Python code, we need two things. The first is the current release of Python from python.org. This includes the Python interpreter, the Python virtual machine, the standard Python libraries, and some other useful tools such as pep8 for checking for style issues in your code. Now, we could run and write Python code just with this. However, it would not be a very enjoyable experience. The second thing we need, and this is going to make our life far easier, is an integrated development environment, or IDE for short. An IDE is a software application that provides a graphical user interface, or GUI, for editing Python code, as well as other development tools to make it easier to write and debug Python programs. This can include features such as syntax highlighting, where code is colored as we typed it, making it easier to understand, autocomplete and hint features that give us some tips and direction while we're writing Python code, and an easy way to run our Python code from the editor, as well as tools for debugging our code and finding errors. For this course, we'll officially be using the PyCharm IDE. All examples I show and instructions I'll give will be for this IDE. But you're free to use any IDE you like, so if you have another that you prefer, just keep in mind that the examples will be in PyCharm, and it will be easier to get help if you're using PyCharm because our teaching assistants will be more familiar with PyCharm. I have another video on how to install this software, so if you think you're going to need help with installing these on your system, please watch that video. They are available for Windows, macOS, and Linux, so it should be available for your computer. Just make sure that for PyCharm, you install the community version of PyCharm and not the professional version, as the community version is free and it's all you're going to need for this course, and to be honest, probably all you need for most Python development. Now let's switch over to PyCharm and take a look at how we would run that last example. Okay, here we are in PyCharm, and I've loaded up that example into a new project. And you can see here we have the code, and it's done all the nice syntax highlighting for us. And if we want to run this code, we can click this play button up here or simply hit Shift F10 on our keyboard if we're on Windows. If you're on Mac OS or Linux, the shortcut might be slightly different. The other way we can run our program, if we have multiple programs in a project, or multiple Python files rather, is by right-clicking on it in the project window and going down to Run. That will run a specific file, whereas this button will run whatever we have selected here. So if it says current file, it'll run whatever we have currently up. Or if it says something like a file name like main.py, that means it's going to run that file. So let's see what happens when we run this. And I should note before we do that your layout for PyCharm might be slightly different than mine. I moved the project window onto the right here just so my head doesn't overlap any code. Yours will probably pop up on the left rather. So when we hit run, we can see a new window opens at the bottom, and this is going to be all the output for our currently running program. So when we run a program, it might have certain output or be waiting for certain input. This is going to pop up in the run window. So right now we can see it says, what is your name? And we have a flickering cursor. This flickering cursor means that the program is blocked because it's waiting for input. So we got to this line, name equals input, what is your name? Right there. And now it's waiting for the user to input their name before it runs the next line. So in this case, we can say Daniel. And now it's got to the second line, which is birth year equals this line here. And it's asking the user, what year were you born in? And it's waiting for input. So I can see 1986. And when we hit enter, we eventually run all this. So it calculates the years ago, it calculates the seconds, and then it finally prints out the final line. So it says, hello, Daniel, you were born 38 years ago, which is 1199164176.0 seconds. Now, it is important to note that the way this program is created works okay if we make a certain assumptions, like we're assuming that the user is always going to put in an integer, a whole number for the year. But if they input something invalid, it might not work correctly. So for the name, it's not a big deal. We could type any kind of gibberish we want. And because the program's just interpreting this as a bunch of text, it's not going to care what we input. It's just going to put that back out to the user. So you can see if we put an invalid name, but we put a valid year, like 2020, it is going to output exactly what we typed in for name, even though it doesn't make any sense. And it is going to calculate the years and seconds correctly for the valid input of the year we gave it. However, sometimes when we put in invalid input, it causes an error. Let's take a look at that. So let's say our name is Joe. And instead of a valid year, let's put in something silly like the word duck. The word duck is going to cause some issues. So if we look at the code, we do have this input line asking what year you were born in, but then we have this other function called int. And what int tries to do is it tries to convert whatever that input is into an integer number. An integer number is a whole number, meaning it has no decimal points. The problem here is the word duck can't really be turned into a number. That doesn't make sense. So as soon as we hit enter, you can see something different happens. We get an error. And what this error is saying is that there's something wrong in our code. We tried to do an operation that isn't valid. We call this a runtime error. And it's important to be able to understand these errors because we'll encounter them a lot when we're working on our assignments, and they give us some hints as to what's wrong. So in this case, we're saying in this file, the ex-0-1.py, that's the current file we have open in our IDE, says on line 10, so that'd be this line here, we have an error with this expression in our statement. And this is the error. It's a value error. Value errors usually are related to different types or not giving the right type. And it says we have an invalid literal for int with base 10. And that invalid input is duck. So it's a complicated way of saying that we can't turn duck into a number. The big hint here is on line 10. So once we learn a little bit more about Python, we'll know how we could account for users inputting invalid values like this, and how we could prevent errors like that. But for now, since we haven't covered that yet, we're just going to assume the user inputs a valid input. And we're back. As we saw in that quick demo, Python will let us know when we encounter errors in some cases. Understanding these errors and knowing how to correct them is a critical skill to have as a programmer. Countering errors as you're working or writing on code is a common occurrence, and it's important to frequently test your code. Even experienced programmers will occasionally make mistakes or have an error in their code. Common trap students fall into when they first started coding is attempting to write their whole program at once without testing it and then attempting to correct the errors after the fact. Rather than trying to write the whole program in one go, you should try breaking the program into smaller parts and testing each one of those as you create it by running it and then checking if the output makes sense and contains no errors. The errors you will encounter fall into a few different categories. We'll go through some of the most common ones. The first category of errors are syntax errors. Syntax is the rules and grammar of a programming language. Just like human languages such as English, programming languages have a grammar and vocabulary to them. However, unlike human languages, programming languages are far stricter, and any violations of their grammar or misspelling identifier names or so on will lead to a syntax error. Syntax errors prevent a program from running until they are corrected, and they can be caused by simple typos such as forgetting to close a quote or misspelling a function name. Runtime errors, on the other hand, are errors that occur when a program is running. Typically, runtime errors are not related or directly tied to syntax mistakes, but rather they're from trying to perform an operation that's not possible or not allowed. For example, trying to divide by 0 would not violate the syntax rules, but would result in an error as the operation is not allowed or not possible. Another example would be attempting to perform an operation on incompatible types, such as trying to perform arithmetic on a string, such as trying to multiply the word duck by 3.14. That just doesn't make sense. The last category of errors we'll discuss are logic errors. Logic errors are not detected by Python and do not stop your program from running, but result in your program returning an incorrect result or not doing what you intended. These are not caused by a mistake in your syntax or grammar, but they are caused by an error in the logic of your algorithm that you're trying to implement. For example, if you're attempting to create a program that finds the area of a circle, but you have the wrong value for pi, let's say 0.134 rather than 3.14, your program would run fine, but the result it returns would be incorrect. This would be an example of a logic error. Logic errors tend to be one of the most overlooked type of errors, especially for those of you that are new to programming. Most new programmers assume that if a program runs, it's correct. However, this is not true. And this is also why it's important to think critically about the output of your programs, and don't assume that your code is correct simply because it didn't crash or cause an error. You always want to be looking at the output and checking that those outputs make sense. Is this code actually doing what we wanted it to do? Let's now take a look at an example of each error type. In the example we have on screen now, we're trying to make a program that converts inches to centimeters. Should input the number of inches from the user, multiply it by 2.54, and then output the result to the user. However, it contains two syntax errors. Recall that these errors are in rules of the programming language. We did something here that violated the syntax. The first error is that we forgot to close our string. A string being any text that we want our program to deal with. The input function here takes a string that has to be enclosed in either double quotes or single quotes. And the issue was that we forgot to close it with double quotes, so Python thinks that even this bracket at the end is part of the text that we're trying to output to the user, when we needed this double quote mark to close it. This would be an example of a syntax error because it has to do with the grammar or syntax of the programming language. The other syntax error in this code is down here in the print line. You can see that we misspelled the word print. Programming languages are extremely literal, and if we misspell anything, including function names or operator names, we will get an error. To correct this, we would just have to rename this to the correct spelling of print. So let's move on to runtime errors. And this example attempts to convert a temperature in Celsius to Kelvin, another unit of temperature. This should be as easy as adding 273.15 to Celsius value, and that will give us our Kelvin value. But this program has a runtime error. Remember that a runtime error is an error that occurs while the program is running and often has to do with an operation not being possible. Okay, let's try running the code and see what happens. Okay, we just ran the program and it's asking us to input a temperature in Celsius, specifically an integer temperature. By integer, we mean a whole number. So for example, 10 would be fine, but like 10.5 would not, because that has decimal places. And what happens when we input 10? Well, we get an error. And if we look at this error, we can see that it is pointing to line 3. It's always important to look at these line numbers because they give us a big clue about where the issue is in our code. In this case, it's saying that it's in this line, k equals c plus 273.15. The error type is a type error, and it says can only concatenate string, str, that's what it means by string, and not float to string. So that's a bit confusing, but the type error is a big clue. Type errors typically happen when Python expected a certain type and we got a different type. So in this code, we're inputting a string value, that means text, and we're trying to add that to 273.15. Do you see what the error is? So the error in this case is a subtle one, but it is because the input function inputs a string, that's text. And then we try to add 273.15 to a string value, like text. This would be like trying to add the word cat to the number 3. It doesn't really make sense. So we have to let Python know that this value of c is a number and not text. The way we do that is with the int function. This is something that we're going to talk about more when we talk about types in Python. However, I wanted to bring it up now because this is a very common error students get, especially when they're starting to program with Python. So if you have an error about an operation not being possible because of types, usually means because you haven't converted the types correctly yet. In this case, we want to turn c into an integer value if we're assuming the input will be a whole number. If it would be a real value, that is a number with decimal places, we'd want to use the float function and convert that into a floating point number. Again, we'll talk more about types later. The last example we're going to look at is one of a logic error. So let's try to calculate the total for a purchase, including sales tax. That's what this program is supposed to do. The program takes the price before tax from the user and then attempts to add the tax to the price. But it contains a logic error. Recall that a logic error does not stop the program from running, but causes the result of the program to be incorrect. Let's try running this program and see what kind of result we get. Okay, we just ran the program. It's asking us price to find total with sales tax. Let's say that we input $100, like we purchased an item worth $100. In theory, this program should calculate the sales tax, 13%, on that, and then output the total price of whatever this product is with that 13% tax. But what happens when we run this? Well, we get something odd. There's no errors, but it says your total is $1,400. $1,400 seems a little bit excessive for a 13% tax rate. And this is a great example of why it's so important to actually think critically about the results you get from a program. There's no errors here, but that result seems somewhat suspicious. Let's take a look and find out why. So the issue here is in our arithmetic. We can see that tax is supposed to be a percentage. In this case, we have it as the value of 13, which should represent 13%. The issue is, in our math, we're just timesing the price by 13, and this gives us an incorrect result. What we should be doing is dividing that tax rate by 100 to actually get the correct value we can use in the math here, or alternatively, we could change tax to store 0.13. And it's important to note in this case, with the logic error, there's nothing Python can do to tell us this error occurred because it doesn't really understand what the purpose of your program is. Remember, computers are very literal, so it only understands the exact instructions you're giving it. That's why on your assignments and things like that, it's very important to make sure that the result you're getting makes sense. So if you had a very simple assignment like this, you should see that the number I'm getting is way too high. This makes no sense, so we should go back and look at our code. Don't just assume because the program runs that is the correct program. And with that, we're at the end of the lecture. Hopefully you learned a little bit about computer programs and algorithms today, and we can now move on to our lectures and readings on Python programming in the coming weeks. Thank you so much for watching, and have a great day.